Alright, so here we go. We are up to 10.1.4 parabolas. Now the reason I have this piece of paper is I want to go over some general things. So, parabolas. First of all, we've dealt with enough parabolas where when I say what's y equal x squared look like, you should just think, oh, it's like that. And you have learned that if I say, okay, what if we put a negative in there? That means my a is negative, which we go, oh, that reflects over the x-axis. So that would go like this. Now, we're going to build a lot onto that, but I want you to know that your general form, y equals ax squared, is the simple version if your vertex is 0, 0. Now if we go shifting that vertex all over the place, like we're gonna, it is gonna be y minus k equals a times x minus h squared. Now what you guys are used to is if this k is over here. So y equals a times x minus h squared plus k. This is what you're used to. Now your pre-calc book is going to start introducing you to this, which is no different than this. These are the same. It's just that you guys are used to this. So if it's like, remember this is your, basically, bx plus c plus d. If you've got something here, plus d means up, minus d means down. So plus k means up, minus k means down. It's the same thing. But if we look at this, things are going to be there's going to be a slight difference. And I'm going to explain that as we go further. The other thing I want to point out to you is, what if we flip the x's and the y's? Well, x equals y squared is simply going to be this. And so x equals negative y squared, I'm not going to talk about it in too much detail, it's just going to go like that. So, notice we got y equals x squared stuff. We know this one from memory, and I like to talk about Pac-Man a lot when I talk about hyperbolas and parabolas. So if y equals stuff, Pac-Man's going to go up, Pac-Man's going to go down. In other words, it's gobbling up points on my y-axis. If it's x equals stuff, or x equals stuff, my Pac-Man is going to be gobbling up points on the x-axis in one of those two directions. Now to build on these, see the vertex is 0, 0, that's why these are so simple. But if I move the vertex, they're going to look like this. X minus h equals a times y minus k squared, or x equals a y minus k squared plus h. I know those are a lot of letters, but now we're going to actually use numbers and it will make more sense. And by the way, a equals 1 over 4c is big, because that's how we're going to find our a, find our a, find our a, find our a, find our a. That formula is huge. Now, with all that warm-up being said, there's one other thing I want to point out to you that's in this drawing, and I'm going to point it out right here. So, a parabola going this way is going to have what's called a focus. Now, if you came in class, we talk a lot more about it. But that distance from the focus to the vertex is c. Notice the letter c is in that formula. But then if we go that same distance, there's this thing that I call in class soil. And I call this a tulip. And I teach the students that the tulip always blossoms away from the soil. Now this thing called soil, math isn't going to call it that. It's going to call it the directrix. And this is C as well. So you can find this letter C two ways. It's from the vertex to the focus, or vertex to the directrix / soil. The focus, that's what this is, focus, you will hear me refer to it as the pistil, because the pistil is the stuff that the bees come to pollinate if this was a tulip. And it always wraps itself around the pistil, but the pistil is the focus. So just trying to get some real world stuff going on here. So this would be a y equals ax squared kind where a is positive. Now if I took this thing and I flipped it, so here's my soil, here's my letter C, whatever that distance is, here's my vertex, and it will go like that, and then my distance C would be here, and there's my focus. So the tulip is still blossoming away from the soil. This would be y equals ax squared, but a is negative, just like we said way up here. That's where this upside down parabola comes from. Now what about this stuff? Well, if I have a parabola going that way, it has a focus, pistil. That distance is C. So the same distance, C, is where my soil is. So this parabola slash flower is blossoming up to the right, wrapping itself around the pistil away from the soil. Now remember, that's a vertical line, so that's going to be x equals some number. This is a horizontal line, so that's going to be y equals some number. And the final thing is soil, vertex, focus. This is C. This is C. There's my vertex. There's my focus. It's going to go like this. And then that is an x equals some number soil. There's your warm-up. So let's dive in now. Now they're going to mess with you at first by rearranging things. And I want something to jump out at you big time. We're not going to use this. We're not going to use this. I included this because this drawing helps you see what I just said. So, what are we going to use? Well, you'll see. But what I want you guys to notice is my A is connected to my squared stuff. My A is connected to my squared stuff. My A is connected to my squared stuff. Hope you're seeing the pattern. They, in this, kind of changed it up. That's why we're not going to use it. Let me pause this a second. So the first thing we're going to do is we're going to turn this thing around, make it negative 8x equals y squared. And now I'm going to multiply this. Now some people say, well, divide by negative 8. Well, multiplying by negative 1/8 is better, and I'll show you why. If this hits this and this hits this, I get x equals negative 1/8 y squared. So now we got to realize that this is an x equals y squared kind. Remember, if it goes up like this, this is a y equals ax squared kind. If it goes to the right or to the left, it's an x equals ay squared. But notice, a is negative, so it's actually going to open up to the left. So I'm going to draw a little picture. And notice, there's nothing fancy going on here. So there's no shift in the y, there's no shift in the x, which tells us the vertex is 0, 0. And now, because this is negative, it's an x equals negative y squared kind, so it's going to eat points along the x-axis in the negative direction. Now notice, this is my a, so that is going to be a vertical vertical shrink, boy, almost lost it there, which means it's going to be quite wide. Now, they don't ask about that. I just throw that in for free. Now, how are we going to find, we got the vertex. The vertex is 0, 0. How do we find the focus and the directrix? Well, we got to find the letter C. Where are we going to get that from? A equals 1 over 4C. Now watch, what's A? And I want you guys to know something. C is a distance. It's a distance, it's a distance, it's a distance. In other words, it's never negative. So a very rare time can you ignore that negative and just bring the 1/8, and you're like, oh, 4 times what is 8? 2, which tells us, here's my tulip. I got to find the focus. It's right there. So that'd be negative 2, 0. That's the focus. Where's the directrix? Well, the directrix is 2 units this way, but it's a vertical line. I'll make it dotted-ish. So that guy's name is x equals 2. So there's the directrix, there's the focus, there's the vertex, 0, 0. I know it says focal width, but we're not going to worry about that. Let's try this one. Again, we're going to flip it around. We're going to bring it into our familiar world. Multiply it by 1/20th. Y equals 1/20th x squared. Now remember, y equals x squared is going to be up like this if a is positive, which it is. Now, because that's a big old fraction, it's going to be very wide. Don't worry about the accuracy of the drawing. We're just getting somewhat perfectionistic. But now, there's my vertex. So my vertex is 0, 0 again, because there's no shift, no shift. What's my focus? What's my directrix? Well, we got to find C. We know that formula, A equals 1 over 4C, so 1 over 20 equals 1 over 4C. We can just look at these two things need to be equal. So 4 times what is 20? C is 5. So I need to go up 5. There's my focus, 0, 5. Down 5. And that's y equals -5. All right, let me pause. All right, so I got a little ahead here just so we could save some time. Find the equation, all right, of the parabola that satisfies the given conditions. So I labeled vertex 0, 0, focus 0, 2. Based on the tulip idea, we know it's going to look like this. Now some of you are like, well, how wide is it? We don't know because we don't know the equation. But at least we've got this drawing, and we know that C is 2. So we know C is 2 from the drawing. We also know this is a y equals ax squared kind. So we're going to figure out what this is by going A equals 1 over 4C, which is 1 over 4 times 3, which is 1/12. And because the vertex is 0, 0, we're done. We just put that right there, and our final answer is y equals 1/12 x squared. We found the equation. How about this one? Vertex is 0, 0. Directrix x equals -3. So in a way, well, not in a way, they're telling us C is 3. We also know the tulip blossoms away from the soil, so we know it's going this way. So we know, number 1, first thing we found, C is 3. Number 2, we know this is an x equals ay squared kind. But we got to find A. That's the third step. A equals 1 over 4C. I'm just going to put that in right now. So we get 1/12. And so, ooh, I screwed up over here. Maybe somebody caught me. C is not 3 over here, it's 2. I don't know where that 3 came from, so that's 2, which makes that 1/8, which makes that 1/8. There we go. So this is 1/12 though. So now I can put that right there, final step. X equals 1/12 y squared. There you have it. Okay, so we're moving forward now. Now they're going to move the vertex on us. So now things are going to get messier looking. Now we're not going to use this. Not going to use this. I'm going to replace this one with y minus k equals a x minus h squared, which is the same thing as y equals a x minus h squared plus k. We'll talk about this in a minute. This one is x minus h equals a times y minus k squared, which is the same thing as x equals a y minus k plus squared plus h. Again, we'll talk about this. So we can see this right here is a y equals ax squared kind. This here is an x equals ay squared kind in general. So how do we do these problems when they're kind of moving the vertex on us? first thing I'm going to do is I'm going to realize my x is my squared stuff, my y is my not squared stuff, so that's taking me to this kind. So I got to make it look like that. So I'm going to flip this thing around. So negative 8 y plus 1 equals x plus 4 squared. Now some of you are tempted to distribute that, but what I'm trying to do is get my y by itself. So what I'm going to do is I'm going to multiply all of this by negative 1/8. We also need an a right here to help us graph it and to help us find other things later. So this times this, these two things cancel. So I get y plus 1 equals, but then that negative 1/8 slides right in there. No, you may not distribute that through this. Remember PEMDAS. You can't, you got to do the exponents first, but we're not even trying to do that. Right now, we can tell, and you guys aren't used to this, so I'm going to take one more step and just subtract 1, and I'm going to write it y equals negative 1/8 x plus 4 squared minus 1. Now you guys are used to this. So here's my A, here's my B, here's my C, here's my D. Now, if we actually tried to graph this, I could say, left 4, 1, 2, 3, 4, down 1, down 1. Now if you like this one better, you just got to remember opposites. Left 4, down 1. If you're going to write it in this form. If it's in this form, opposite, obey. So either way. But now we do know this is a y equals ax squared type. This is negative. This is going to make it wide, and it's going to go down because it's a y equals x squared kind with a is negative. Now with that being said, we got to find the focus and the directrix. Well, a equals 1 over 4c. What's our a? It's right there. You can ignore the negative. I know that feels strange, but we're trying to find c, and c is a distance. 4 times what is 8? 2. So c is 2. So that tells me, because this point is right here, negative 4 down 1, it's a little off, but there it is. I need to go 2 up to find my soil. So that would be y equals 1. I need to go 2 down from here, which is negative 4, negative 3. There's my focus or my pistol. So that gets a little more challenging when they start messing with the vertex. All right, I got to erase that thing at the bottom there. Actually, I don't. It's perfect. I don't know why I put it in there, but here we go. Focus is 2, negative 3, so 2, negative 3. Directrix, x is 5. Vertical line, x is 5. 1, 2, 3, 4, 5. I guess I did screw it up. So x equals 5 would be 1, 2, 3, 4, 5. And there it is. X equals 5. So we got to find the equation. Well, if we know the focus is 2, negative 3, which is the pistol, that's why I teach it. Directrix is the soil. We know, I'm going to rearrange this because it's in the way. That's 2, negative 3. That's my focus, which is my pistol. That means my vertex needs to be right smack dab in the middle, which if we just think about it, this is 5 over, this is 2 over, so this gets a little hairy, but from 2 to 5 is 3 units. So from here to here is 3. That means this little piece is 1.5, and that's the same thing for this. So C is 1.5. But it's also telling me it's going to look like that. So I know right now it's an x equals ay squared kind just to get started. I also know that my vertex right there would be 3.5, 1.5 to the right of 2, comma, negative 3, because that's equidistant down. So I'm going to make some adjustments here. So I'm going to go x equals a, we'll find that later, y squared, here's my y, plus 3 squared, and then plus 3.5, because that's 3.5. I know things are flipped on us, but that's 3.5 to the right. So now I got to find A. Well, A equals 1 over 4C. C is 1.5, which is 1/6, but it has to be negative because my Pac-Man is heading in the negative x direction, and that's pretty dang tricky. You got to go with the picture to help you. Now I'm going to put that right here, and I'll be done. So x equals negative 1/6 y plus 3 squared plus 3.5. And there's our equation. That one's a little tricky. All right, I know this is a long lesson, but here we go. Last two problems, and then you guys can be released into your homework. But this says, write the following in graphing form. We got to first look at this, and we got to ask ourselves, is this going to be a y equals ax squared or an x equals a y squared? Well, you can see my x is squared, my y is not. So it's going to be one of these. Well, what does that help me with? Well, first of all, I don't want negative y, I want positive y. So I'm going to add y to both sides, and now watch what happens. I'm going to add y to this side and flip it around. So y equals 2x squared plus 8x plus 13. Now there's going to be a little twist coming up here. So first of all, we got to complete the square because this needs to be a 1. Now I can't divide everything by 2 because I don't want y over 2. So what I'm going to have to do is take a 2 out of just these. This thing I'm going to slide over. So I'm going to get 13 plus something in a minute. Now watch this. If I take a 2 out, I get x squared plus 4x plus space. This is a little different. Take half of this is 2. 2 squared is 4. That's what goes in here. But look, on the right, this is my equals. So I just put 8 on the right hand side. So to keep it balanced, I got to put a negative 8 because these are on the same side now. And that's the difference. Now I'm going to clean this thing up. X plus 2 squared, 13 minus 8 is 5. And now we've got it in graphable form. We go left 2, up 5, vertical stretch, yada yada. All right, how about this one? Well, notice that x is sitting by itself. So what we're going to do is we're going to subtract everything else, or I mean get everything else on the other side. And so these cancel, these cancel, these cancel. So I end up with x equals negative 3y squared plus 6y. Now watch this. Well, I'll just do it later. So there we go. What do we do with that? Take our constant, slide it over. What can we do with this? Well, we can take a negative 3 out, because remember what we need here to complete the square? We need a positive 1. So that's why we have to take a negative 3 out. So up with y squared minus 2y, because a negative times a negative gives us our positive, plus space, minus 7 plus space. Take half of that, negative 1, square it, 2. Be careful here, negative 3 times 2 is negative 6, so I got to add a positive 6 because this stuff is on the same side. And that's just the way it is with a parabola. So we go x is negative 3, y, that's supposed to be a 1. Okay, because we square this, looked like a 2 to me. So we get minus 1 squared minus 1, because that's negative 1. And this factors into this. And now we could graph this if we were told to. All right, long lesson, but I think you guys are ready to rock and roll.